Let's find the equivalent resistances of some circuits. By equivalent resistance, we mean the single resistor that can take the place of two or more resistors in a circuit that will provide the same current and energy drawn by the voltage source. Here we have a 6 ohm and a 4 ohm resistor, in series, also in parallel. I'm keeping the numbers simple, no mathematical challenge here. We concentrate on the ideas. So we see the equivalent resistance of resistors in series is simply their sum, 10 ohms. For the same two resistors in parallel, recall the reciprocal formula, where the reciprocal of the equivalent resistance equals the sum of the reciprocals of the others. But remember, for only two resistors in parallel, we can use the product over sum rule. Here we have 6 times 4 over 6 plus 4. We get 2.4 ohms, much less than the 10 ohms in series. Now never mind that the 2.4 ohms has an extra significant figure compared with the 6 and the 4 ohm resistors. At this stage, we'll put this kind of numerical accuracy in the back seat, okay? The idea to learn is that the voltage source sees a pair of resistors as a single one, 10 ohms when in series and 2.4 ohms when in parallel. Onward to a combination series parallel circuit, and a rather simple one. Note resistors in the top parallel branches are identical. There's a better shortcut than the product over sum rule here. For identical resistors in parallel, the equivalent resistance is half the value of either resistor. So the 2 ohmers in parallel are equivalent to a single 1 ohm resistor. A nice shortcut that we use again for the pair of 3 ohms in parallel. See the progression? And we end up with 1.5 ohms. Again, very simple. If you want challenge, if you go further with electric circuits, you'll get plenty, imaginary numbers and all that. But for now, let's just move on. Here we have a complex circuit with a battery. Suppose we're asked to find the current in the battery and the current in the top 4 ohm resistor. We'll keep that in mind as we progress. The pair of 4 ohmers gives 2 ohms, and the 3 plus 7 ohms in series add to 10 ohms. And we have a pair of 10 ohmers in parallel, so we get 5 ohms. Now, what's the current drawn from the battery? Well, from Ohm's law, you get 60 volts. 12 amps. That's 12 amps in this circuit, and in the others. In this circuit, we see that the 12 amps divides into two 6 amp currents. Likewise with the others. And in the original circuit, we see the 6 amps in the top branch divide evenly between the 4 ohm resistors. So there's 3 amps in that top 4 ohm resistor. The answer to our initial question. 12 amps supplied by the battery and 3 amps in that uppermost branch. Yum! Now here's an interesting sequence of circuits. In circuit A, we see 2 1 ohm resistors in series, which together are in parallel with a 2 ohm resistor. So that gives us what? We end up with 1 ohm. So in 2 steps, we see that the equivalent resistance is 1 ohm. Yum! Notice that circuit B is quite similar. In 3 steps, we find we have the same circuit that we started with in circuit A. So the equivalent resistance of this circuit is also 1 ohm. That means a battery wouldn't know the difference if it were connected to circuit A or circuit B. They're both equivalent. Yum! Now I want to leave you with this granddaddy circuit C. Suppose the battery is 6 volts. How much current is drawn by the battery? How much current is in the first 2 ohm resistor? And how much current is in the first 1 ohm resistor? Got it? I hope so. Until next time, good energy to you.